Now, rather than the mechanical properties, we may have some physical forces may do a work on the materials, may change the properties of the materials. So we have something called the physical properties of the materials, which are the properties that define the behavior of the materials in response to the physical forces rather than the mechanical forces. And these properties can be volumetric, it can be thermal, it can be electrical, and can be electrochemical properties. It's very important in manufacturing because the physical properties often influences the process performance. For example, in the machining, the thermal properties of the work material determine the cutting temperature, which affect the tool life. Now we know the cutting tool, and this is what you are going to see actually in the case of the turning process and the milling process. We're going to have direct contact between the cutting tool and the material. Now, if I'm going to have higher temperature to be generated between the cutting tool and the metal, that means we're going to reduce the cutting tool life. Okay, that's why the thermal processes are very important in the machining process. In the microelectronics, the critical properties of the silicon is the basis of the semiconductors manufacturing. So first we're going to talk about the volumetric and the melting properties. So any properties which are related to the volume of the solid and how these properties are going to be affected by the temperature, like the density, thermal expansion, and the melting point. Now, we mentioned in lecture number 1 that definitely by heating up any metal, we are going to have an expansion in the volume. If we are going to have expansion in the volume, and that's what we actually call the thermal expansion, we are going to reduce the value of the density. So the density is how much mass we have per unit volume. That means how many grams of mass we are going to have in 1 cubic centimeter volume, or how many pounds we have in the cubic inch volume. The specific gravity is the density of the material relative to the density of the water, which is the ratio with no units. Now an example for that is that, for example, the density of the steel is equal to 7,800 kilogram per cubic meter. What is the density of the water? It's 1,000 kilogram per cubic meter. So to find the specific gravity is simply again to divide the steel density 7,800 by the water density of 1,000, and the result is going to be 7.8. So the specific gravity of the steel is 7.8. Now for the density, it's important in manufacturing in consideration of the material selection for a given application. But it not be the only property of the interest we are going to have. The strength may also be important, and definitely strength is different from the stress. Okay, so strength is different from the stress. Okay, and it's going to allow the properties are going to be often related to the strength to weight ratio, which is going to be the tensile strength divided by the density. The usual ratio of and comparing the materials for structural of applications like the aircraft, the automobiles, and other products where the weight and the energy are going to be concerned. Now, usually in the case, for example, the aircraft or the automobile, or even the engine block in the automobile itself, we always try to find a good strength to weight ratio. Okay, always have a good strength to weight ratio, because we would like to have a higher strength for the material with lower weight of the material. And that's why we're using the aluminium in the structure of the airplane skeleton rather than using the steel. The steel is too strong, have higher strength value, but the weight is going to be higher. So the strength to the weight ratio is going to be lower than the case of the aluminium. The thermal properties are the properties that the temperature determines the thermal energy level of the atoms, leading to the changes in the material. For example, like the thermal expansion, we are going to have the melting temperature, and the heat of fusion we are going to add to do the melting process. And other additional thermal properties are the specific heat of the material, the thermal conductivity, and this properties relates to the storage and the flow of the heat within the substance. The thermal expansion, where the density is going to decrease with the increasing of the temperature, okay, and the volume per unit weight increases with the increases of the temperature. Now, why the density is going to increase with the increasing of the temperature? Because the volume is going to increase. Density is the mass divided by the volume. The mass is going to remain constant, but the volume is going to increase. That means the density is going to decrease. The effect of the temperature on the density is called the thermal expansion, and it's measured as the coefficient of the thermal expansion we are going to have, which is different from one material to another. And the alpha, which is coefficient of the thermal expansion, which is the change in the length per degree of the temperature. And the unit is going to be how many millimeters we are going to have to increase per how many original millimeter we are going to have, and this per each degree of the temperature we are going to add. And the alpha can be calculated from the following equation. The thermal expansion is very useful, especially in the cases, for example, like the shrink fit and the expansion fit assemblies. So what we have in the image you can see in front of you, that we are going to fit the shaft inside pushes or ring. So this ring inner diameter is smaller than the outer diameter of the shaft, but we want to fit these parts together. So the only way to do that is we can go again to heat the ring, so the size is going to be expanding, so we are going to have less force to be applied to push the shaft in. When it's going to be cooled down, it's going to shrink and fit all the shaft, and this will hold the parts together.